The topic for today is factor theorem. If we have a polynomial px with a degree 1 or more, and I find the value of PA, that means I am taking x equal to A. In case PA becomes equal to 0, then x minus A is a factor of Px. This will be understood better if we take an example. Let's take a polynomial Px as x square plus 4x plus 3. I tried to take the value of x equal to 1, and by the hit and trial method I am going to try to find a 0 of the polynomial. Why a 0 of the polynomial? Because I want that particular value of a which will make the polynomial a 0 polynomial. So by the hit and trial method we try. I take x equal to 1. So this is a 1 square plus 4 into 1 plus 3. This is a 1 plus 4 plus 3. This is equal to an 8. Not equal to 0. That means x equal to 1 is not a 0 of the polynomial. So x minus a is not a factor, means in this case x was equal to 1. I transpose a 1 here. X minus 1 is not a factor of the polynomial. Let's take now x equal to a minus 1. This is p minus 1. Let's substitute the value of p minus 1 over here. X is a minus 1, so this is a minus 1 whole square plus 4 into a minus 1 plus a 3. We simplify. This is 1 minus 4 plus 3, a 4 minus 4, which is equal to 0. Therefore, p minus 1 is 0. This implies x equal to minus 1 is a 0 of the polynomial px. Let us transpose the minus 1 over here. When we transpose the minus 1 over here, x plus 1 is a factor of px. So basically by the hit and trial method, we will first try to put values of x in the polynomial to check, does the polynomial become a 0 polynomial? When it becomes a 0 polynomial, for that particular value of x, it is a 0 of the polynomial px, and we transpose the number on the left hand side, and x plus 1 becomes a factor of px. Let us check this by the division method. So we divide x square plus 4x plus 3 within x plus 1. Now when I divide this, I try to obtain x square from an x. I multiply with an x. This is then x square plus x. We subtract. This is a 3x plus 3. We then multiply the 3 with x and with a 1. We get a 3x plus 3. This cancels out and the remainder is 0. Now since 0 is the remainder, therefore x plus 1 is a factor of x square plus 4x plus 3. Next example we take is a cubic polynomial, x cube minus 2x square minus x plus 2. Now by the hit and trial method, we have to try to find a particular value of x for which this will become a 0 polynomial. Here I will give you a hint. Whatever is your constant term, 2 in this case, find the factors of 2. Now the factors of 2 are 1 and a 2. But in this case, we write it as a plus minus 1 and a plus minus 2. Now why do we do this? Because 2 is divisible by a plus 1. In that case, the quotient becomes a plus 2. Similarly, if you are dividing it by a plus 2, you're getting a plus 1. But 2 was also divisible by a minus 1. In that case, if you divided 2 by a minus 1, you get a minus 2. So now onwards, whenever you're going to write down the factors of any number, and in this case it is the constant term, you write down the factors as a plus minus of that factor. This will give you a hint about what values to take as the value of x. So we try with x equal to 1. So this polynomial at x equal to 1 is a 1 cube minus 2 into a 1 square minus 1 plus 2. We simplify. This is a 3 minus 3, which is equal to 0. So at the first instance only we have got the 0 of the polynomial. So if P1 is equal to 0, this implies x equal to 1 is a 0 of the polynomial. We transpose 1 to the other side. X minus 1 is a factor of the polynomial px. Now, this is the factor theorem. So, coming back, if you have a polynomial px for a certain value of x equal to a, at pa, if this polynomial becomes a 0, that means x equal to a is a 0 of the polynomial. We transpose a to the other side, then x minus a is a factor of px. This is the factor theorem. The application of the factor theorem is you may be asked to find out the factors of a polynomial using the factor theorem. So here, when we use the factor theorem and we got this polynomial on dividing by this, we were getting an x plus 3. So we could write it as x square plus 4x plus 3 is an x plus 1 into an x plus 3. So this is factorizing a polynomial using the factor theorem. Previously, we have learned how to factorize a quadratic polynomial using the splitting the middle term, but you may be asked to factorize it using the factor theorem. Similarly, for this one that we just took, if I am asked to find out the factors of this cubic polynomial, then using the factor theorem, I got one of the factors as x minus 1. Now, we will divide the polynomial by x minus 1 since it was a factor. This is x square, multiply with both the terms. This is x cube minus x square. Taking care that like terms come under like terms. This is a minus, this minus becomes a plus. This cancels out. We now pick it up as a minus 2x square plus x square, which is a minus x square. Bring down the next term. Minus x square divided by an x is a minus x. We multiply again with both the terms, minus x square plus x. This minus becomes a plus, cancels out. This plus becomes a minus. Minus x is a minus 2x plus 2. Minus 2x divided by x is a minus 2. Minus 2 into x is a minus 2x. This is a plus 2. Again signs change and the remainder becomes equal to 0. Getting the remainder as 0 reinforces that x minus 1 is a factor of this cubic polynomial. But we had to find out all the factors. Now the quotient that you get is again a quadratic polynomial. So this quadratic polynomial, I could again find the factors either by splitting the middle term or I could have used the factor theorem. Here I am using splitting the middle term. a plus b is a minus 1 and the product is a minus 2. Now this being negative means one number is positive, one number is negative. The factors are 2 and 1. This being negative means the 2 was negative, 1 was positive. Let us check. My negative 2 into a positive 1 is a negative 2. A negative 2 plus a plus 1 is a negative 1. We split using these signs. This is x square minus 2x plus x minus 2. X is common, x minus 2 plus 1 is common, x minus 2. So this is x plus 1 into an x minus 2. Now the question was to factorize this cubic polynomial using the factor theorem. So px, which was equal to x cube minus 2x squared minus x plus 2, can now be written in the factored form as x minus 1, which was the first factor, into x plus 1 into an x minus 2. So we have used the factor theorem to factorize a cubic polynomial.